everyone, welcome to GDC Classes English. So today we are going to discuss regarding the powder flow properties. So by this series, I think you are getting the benefit that you have wanted. You have been able to actually streamline the syllabus. As per these videos, we have prepared the material based specifically on your pharma related competitive exam, be it GPAT, NIPER, DI or any other pharmacist exam, so that you can clarify the concepts, polish yourself as well as try to attempt the questions in the other half of the video. Okay, so please let's start the topic. Stay tuned with the video. At the end of the every video, I try to add certain questions from the similar topic. As well as what you can do is to try to comment down your responses, how many of you have got that right. And if you have any issue in any topic or any point you think has been missed or what else you are expecting, you can write down in the comments below. Okay. So let's start with our topic, that is the powder flow properties. Now, why this topic is actually important? Why do we need to study or evaluate the powder flow properties? See, whatever formulation we are making, let's take an example of tablet, right? In tablets, no two tablets have similar excipients based on their profile, based on their active pharmaceutical ingredient and the proposed activity. Their excipients can be really different as the API is. So we have to formulate it to get into a tablet formulation. Alright. But the final packing geometry, right? Final packing geometry is actually based on how the excipients were processed. Now these excipient processing is based on what is their own nature, right? How is their particle behavior? So ultimately it comes narrow down to the performance of the formulation, to the quality of the excipients. So final performance of your formulation is dedicatedly impacted by the nature and type of excipients, right? If you have a powder with a poor flow properties, their entire packing geometry will be different. If the packing geometry is different, so will be their release behavior, their dissolution, their absorption patterns, everything is impacted. So that is why we should be able to evaluate the powder flow properties. Now there are actually three methods by which you can evaluate the powder flow properties. One of them is most important from an exam point of view is the Kār's index, right? We have here is the Kār's index. Kār's index, or we say it is the compressibility index. Kār's index, or we say it is the compressibility index. Okay, Kār's index is based on the tap density minus bulk density upon tap density into 100. Alright, so for any powder, if you calculate its tap density, its bulk density, you use the formula, you will be able to get the value of the Kār's index. Okay, so tap density minus bulk density upon tap density into 100. This is the formula of the Kār's index. Tap and bulk density, if you are confused anywhere with it, bulk density, that means just the powder, if it has been poured, there is no voids that has been removed, right? So kind of we are not actually talking about the true volume, but the actual volume of powder plus voids, that will be the bulk density of the powder. But if you keep on tapping, this tapping motion is going to reduce the presence of voids. The voids will be eliminated, powder geometry will be now different. So that will be tap density, right? With the initial amount of that powder, you get the mass upon volume. So tap density is mass upon tap volume. Bulk density is mass upon bulk volume. So you just put by the calculated value as tap minus bulk upon tap into 100. So this is our Kār's index. Okay, Kār's index has multiple values. Based on its values, we evaluate that the powder flow is poor, the powder flow is good or passable, right? For example, if you see here compressibility index, if the value is less than equal to 10, we have an excellent flow. If the value is less than equal to 10, you have an excellent flow. If the value is between 11 to 15, it will be good flow. Very important from exam point of view. Okay. If it is 16 to 20, you have fair flow. If it is between 21 to 25, you have passable flow. If it is between 26 to 31, it will be poor flow. If 32 to 37, you have very poor, and more than that 38. Now you may wonder, ma'am, how will we be able to memorize this much? How we will categorize this in our head? So let's see a simple shortcut by which we can evaluate this, right? If you have a value less than equal to 10, you have the excellent flow character. Just remember the highest one. Then there is a gap of 4 in the next. From 11 to 15, you have good flow. Then 16 to 20, then again here we have a gap of 4. Then 21 to 25, gap of 4. 26 to 31, gap of 5. 32 to 37, gap of 5. And then 38. So just by remembering the gaps between the digits, you will easily be able to compute for the powder flow. Okay. So Carr's index, now you have seen, if you just put the simple formula of tap minus bulk upon tap into 100, you get the values. By these values you get the actual flow character of the powder. Okay. Not only this, we have another important part where we can calculate it by the second method, that is Hausner ratio. Number one is the Carr's index, second is the Hausner ratio. Similar to the Carr's index, Hausner ratio also uses the tap and bulk densities, right? For example, Hausner ratio is tap density upon bulk density. Hausner ratio will be tap density upon bulk density. Similar to the Carr's index, here also we have some values. For example, if the value lies between 1 to 1.1, you will have an excellent flow. Okay. If you have 1.12 to 1.18, you have a good flow. If it is between 1.19 to 1.25, it will be a fair flow. If it is between 1.26 to 1.34, it will be a passable flow. If the value is between 1.35 to 1.45, it will be offering a poor flow. If it is 1.46 to 1.59, it will be very poor, and more than that, it will be very poor. But please, this is my personal request to you all. This topic is very important. So as you have to remember the formulas and ranges, there is no other way out. Okay. Definitely one or the other questions you may spot in your exam. Okay. So just like in the Carr's index, you got with the difference. Here also, let's suppose in the first one, you can see it is 1 to 1.1. Okay. Then we have 1.12 to 1.18. That means around 0.06. Then also around 0.06. Then 1.26 to 1.34. Around 0.08. Then 0.1. Then around 0.1. Right. So you can get an idea of the difference in between the value. Just try to remember the highest one, the lowest one, and the difference around. It's not you should remember the exact values. The buffer range also works. Okay. So by now it must be clear, flow property can be calculated by three methods, of which we two have discussed. Number one is the Carr's index. Number two is the Hausner ratio. Okay. Let's move back to the angle of repose. So we have angle of repose, which is the maximum possible angle. Kindly look here. It is the maximum possible angle between the surface of a pile of powder and the horizontal plane. Let's understand this with an example. For example, you have a certain amount of powder. This is a simple funnel. You add your powder here. What happens? A heap of the powder bed is formed, right? Now, if this heap is formed, you can take a simple scale. You can measure the height of the heap. You can also measure the radius of the heap. You can measure the height of the heap. You can measure the radius of the heap, and you get the expression as tan theta is equals to h upon r. That means height of the pile and the radius of the pile. Okay. So this is a simple way you can get the value of angle of repose. Similar to Carr's index is Hausner ratio, we have the value as less than 25 offering the excellent flow. Okay, 25 to 30 offering the good flow. 30 to 40 offering the moderate flow, and greater than 40 we have poor flow. Okay, please try to remember these values. These are really important. Okay, next point you must remember, rougher the surface, rougher the surface, higher will be the angle of repose. I repeat again, rougher the surface, higher will be the angle of repose. Once the angle of repose is high, that means the powder flow will come out to be really poor. Okay, so these powder flow values of all the different powders can be impacted. Okay, so you have three methods of evaluation. Now let's come to our questions. Number one question, the angle of repose is calculated by tan theta is equals to r by h is equals to 1 plus r by h, 1 minus r by h, or r by h. So for those who remember, it is tan theta is equals to h by r. That means height upon radius. There should not be any doubt about it. Okay, simple, based on the formula they have asked you. Option D here is correct. Okay, next question. Okay, if the Carr's index value is 10%, then what is the type of the flow? Carr's index value, if you remember, how did you calculate the Carr's index? It was tab density minus bulk density upon tab density into 100, right? Next, if you were be able to given the values, you get as 10%. That means if the value is around 10%, you get the excellent flow. Remember, then it was 11 to 15, then 16 to 20, then 21 to 25, and so on, then 26 to 31, 32 to 37, and greater than 38. So you get the excellent flow at the Carr's index value 10%. Okay, so excellent flow, right? All other values are very easy to remember. You just need a one or two revision, it will all be done. Next, free flowing powders show a flatter cone and have smaller angle of repose, larger angle of repose, intermediate, and none of these. See, if the powder flow is not good, that means here the angle of repose would have been larger, but it says the powder is free flowing. That means it will offer a smaller angle of repose, right? So we have our option A as the correct answer. So free flowing powders do show a flatter cone and it will have the angle of repose which is smaller. If the value increases up to 40-50, that means the angle of repose is actually very high and the powder flow will be considered poor. Okay, I hope this topic is understood to you all, and believe me, it is very important. So thank you so much. We are going to continue with this series and we'll meet you in our next video. Thank you so much.